Today I want to give you some examples of how to do what we call scanning for crystals at any CAT on either beamline. And today I'm using the 24 IDE beamline. There's a couple prerequisites for scanning crystals. What you really need to establish is what we call a spanning vector. And you can see I've made a spanning vector here. So I've centered on this point and hit save for the 3-click centering, and then I center it on this point over here and hit save a second time. And I get this nice line drawn between the 2 points. And what you really want to do when you're scanning is to span the loop as much as possible. You don't want to make a little vector, even if you have a good guess at where your crystal is. Like I have a good guess that my crystal's here. Since I'm doing scanning example, that's why I'm scanning a crystal I can see. But you want to span the loop as much as possible. The other thing I've done to set up, which isn't necessarily what you need to do, is open the viewer. So I hit the viewer button here on the images tab, and what it does is pop out this image viewer, which will display any data image that I click on. So if I click on some old images I have, you can see it'll pop up the same image. And that's handy for scans. So in the Scan tab, we have 3 choices for different types of scans. We have line scan, grid scan, and vertical scan. First type of scan we'll try is a line scan, and that's good for a case where your crystal is long and you want to see if it's homogeneous across its entire length. This is the most common use case. We do so, we're in the Scan tab, and we will use the line. And you can see we get this control panel that has different parameters we can set. We can modify the number of points we want, the aperture size, the distance of the detector, the transmission. When there's more parameters we can set, non-standard parameters, if you click the gear icon, you can manipulate things like the delta omega for the scan, the time for the images of the scan, the low and high resolution cutoffs for the analysis. Generally you don't need those, so they're hidden, but by all means, if you need them, use them. So then we hit define scan, and the scan should be initiated, and it should come back to us with points that it is planning on collecting, just for us to give the OK to. And should take a few seconds. There's what it's going to do. If we want to change them, if we want more points, less points, or something like that, we can modify. But in this case, I'll just go ahead and hit go. And it'll set us up and collect the data for us. If we had changed the detector distance, that would appear down here in the bottom right. It would go orange. And we'll go ahead and collect. And it will try to color based on what it sees as the good spots values. And for example, we can rank here on the best good spots, and that's what it's colored by. So we can hit the second image or spot, and it'll show us an image. And we have lots of spots, so which is good. It should be green. And then the red regions should have less spots. You can see that here. This table, though, is actually there's different parameters you can sort on. Mean signal is a good parameter to sort on, and you can see that the mean signal is actually it's a lot higher for down here where we have a real crystal. Even though it has less spots, you can see that what we have is actual real diffraction from a crystal. From a single crystal is what we want. So if you click on good spots over here, it will show you the histogram of good spots. If you click on the resolution, it'll show us the resolution, which is probably not as useful. And then mean signal, there's mean signal. Okay. So that's a line scan. Once you have a spot, you can go ahead and move to that selection spot. So say, for example, I want to try over here, spot number 3. I'm going to go ahead and move to selection. It'll move to the point. Okay, and then if we exit out of this, we can see we should be centered all the way over there where I selected. Excellent. Okay, so the next type of scan we'll try is a grid scan. And when I hit the grid scan button, it will move the crystal to the center of this vector that we made. So it'll center right on there. And again, we have a number of parameters we can modify. There's 3 grid modes. There's a fill mode, which will fill a box that you draw by click and dragging with spots. A loop mode, where it'll try to find the loop and then fill that with spots. And then the hybrid, which is you drag a box and it'll find the loop, and then the union of those two, it will collect. So we'll go ahead and do a loop. That's what I would recommend usually. And you want to be centered so you have a nice big picture of your loop, but you don't want the loop too big. So you don't want a case where your loop actually overranges the image, because that's not so useful. So this wouldn't be good because the computer would not be able to define where the loop actually is. It wouldn't understand that. So what it needs is a nice, well-defined image with edges and that it can understand and can sort of wrap its mind around. So something like this. Scan mode is probably not so consequential. You can look at the manual for a lot of these parameters. The aperture size is pretty consequential. The overlap, probably want a little bit of overlap like this. And, I'd pick a good transmission around 10%. And then, as we did in the line scan, we define the scan. So this is called a primary scan because we can do a primary grid scan and then a secondary grid scan based on that first one. And so what we'll do is the same routine where we'll write parameters, and then it should return to us with what it thinks. Okay, so it zoomed out for us. I guess that was the machine saying it's too close together. And we can go ahead and go. We like this one. So what we have is our spots where they'll be, and they should be numbered. And the computer should then collect our data for us. Over on the right-hand side, we have the scan specifications, so describing what our scan was like, what its parameters were. We have a result. So now that we have a primary grid scan result, we can go ahead and look at it. There was a little crystal over here somewhere, I think, yeah. So there's lots of little crystals, lots of diffraction here, and you can see that there's multiple crystals all piled up on top of each other. What we really want, of course, is our single crystal, which is over here. And what I will do is I will go ahead and find the best mean signal is position 55. So that's the best by that metric, and it looks like a good single crystal. And what I want to do is now scan around 55. And the way to do that is, since I've clicked on a spot, I now have a secondary scan is available. I'll hit secondary. It'll give me the panel. I don't really want to change the zoom, so I'll keep my zoom as 5. But I'll use a smaller aperture with a nice overlap, and I'm still going to stick with 10% and hit define secondary scan. And so what that will do is flip us over into the mode where we see the live image. It'll draw the cross that marks where the beam is, so you can see we center that position. And then we have to select the area to scan. I can see this crystal, but say I couldn't see it. I'm going to pretend I can't see it and think it's here. So that's a reasonable box to draw. And then I'm going to tell it that I've selected the scan, and it'll give me the points that it's going to scan. Okay? So I will go ahead and, okay, now that's done, we can go ahead and select our best spot, or however it is we want to go about it. It's saying down here's the best. You can move wherever you like. So we'll go ahead and move to that spot. And again, it should say moving to point. Now it's done. And we can go ahead and look at this. Okay, that looks reasonable. Maybe that's just the best part of the crystal or whatever. But we want to go ahead and do a vertical scan because now that we're centered in this two-dimensional plane, we want to center in the other. So I'll flip it around by 90 degrees. Okay. And we can see the crystal in this case, but we want to go ahead and do it for test's sake. I'll hit vertical scan. And again, you have different parameters you can modify. But in this case, you have to draw a box of where you think it is. Basically the extent that you want to scan. Go ahead and hit define scan. Again, as normal. Okay, go ahead and go. So again, you can look at the good to be spots. You can look at the mean signal. Pick your parameter that you feel is the best for your case. It varies. And you can go ahead and move that selection. So now we're centered in, hopefully, 3 dimensions. Just a couple things. If you want to review the data that you've taken, it's all up here under select data. So you can go back and look at your older scans. You can go back, we've done the vertical scan, but we can go back and look at the grid scan. You can look at the secondary scans you've done. If you still have the crystal mounted, so this is N0, so sort of a nonsensical position. So if you still have your sample mounted, you should be able to move back. So I could move back to any of these samples. They're N0. Can't move back to older ones, but you can feel free to look at them. All the data should still be there. You can even, if there's a secondary scan, look at that.